Hi boys and girls, it's me Butch. My name is Terry David Silvercloud. And I mostly go by Butch, but you can call me whatever you want, I don't care. I'm about to be 74 next Wednesday. And, I believe that I'm an atheist, so I don't believe in an afterlife. And being 74, I'm lucky if I'll wake up tomorrow. And that it's my duty to follow my passions, and if I have an idea and I don't write it down or express it, it might just get lost, and it just might get lost anyway, but at least if I gave it my best shot to write it down or record it somehow, then I tried. So today is Saturday, the 20th of October, 2018. Started off cool and foggy in Vancouver, here where I live. And it's sunny right now, and it is just after 2 p.m. And today I was thinking, I think a lot, I'm into physics. Physics is the study of energy, matter, and motion, and if you're watching this, you're probably into physics. I can't imagine why else you'd be watching it. But I'm an old fart, and I'm into theoretical physics, and the beauty of theoretical physics is you can let your mind wander and think about what ifs and what ifs. And many theoretical physicists, there's a mouthful, do it mathematically, but I'm not into math anymore in my old age. I got into photography and painting and art, and I didn't get to be a practicing physicist, so now in my old age I ask a lot of what ifs. And because I rely on my imagination and being an artist and all, it goes into all kinds of interesting places. So I've come up with some interesting answers about reality, because if you're into theoretical physics, you may be working at the lowest or fundamental levels of reality. Most physicists that practice physics are busy making use of what we already know. And we've been doing a lot of that in the last 50 years. We can make a lot of things, but we don't understand a lot of things. There are a lot of theories out there, and remember, they're theories. I don't believe in Big Bang. I'm a multi-universe kind of a person. Like Big Bang defies a whole lot of fundamental laws of physics, so I'm not into that. And if you want to have your Big Bang, then it probably had something to do with the creation of our galaxy, but certainly not everything that's out there. That's just plain silly. I'm not going to get into that. But if you're a physicist, boy, that's a hard one to say today. If you're into physics, you should know I think Big Bang is just plain silly, and if you believe it, it's probably just because that's what they taught you in school and you never questioned it ever. So way back when, Isaac Newton, who gave us a lot of our fundamental basic ideas and laws in modern physics, he recognized and stated that absolute time and absolute measurements even possibly are not possible, but certainly absolute time was simply not measurable, and because of that, every observation we will ever make will have relativity issues. So long before Einstein, Isaac Newton recognized issues of relativity, and relativity is not complicated on the face of it. It just means that because reality depends on the reception of reality, you being you out there and me being me here. If there's two different people in two different places in an audience, it should be obvious to you that the sound waves will reach one person sooner than closer to the stage than one further away. So that's sort of the fundamental basis of the ideas of everything is relative to something else. And time is no different. And in the modern age, we've come up with standard time. Standard time was a Canadian invention. Yay, Canada. Won't get into that, but standard time was a Canadian invention. And so we all use the same clocks, and our clocks are getting pretty accurate. But all time is relative, and when you, in the world of physics, if something happened at a certain time, there are certain elements in the world of reality and physics when you ask questions is like, well, where was Earth when that happened? So Einstein got into that, and he proposed mathematical ways of caging ideas and looking at what that thing would look like there in the future, as it were. And I think Einstein made a few, I don't want to call them boo-boos. He just, in 1916, the idea of waves, they were all brand new. And in Isaac Newton's time, the idea of the speed of light, they didn't understand that at all. So when Isaac Newton sort of dismissed absolute time, the very concept of the speed of light and gravity waves and radio waves all having a fairly constant velocity through time and space, which, we would think of as approximately 186,000 miles per second. I'm old school, and approximately just less than 300,000 kilometers per second. Did I get that right? It's very hard for us old dudes, who had to switch to metric in our 40s and 50s to have these other numbers easily. I have a kind of problem. It's not dyslexia, but I have to be able to visualize things to understand them, so I can be slow to memorize certain things because I have to have some sort of visual reference to make it happen. So anyhow, back to the speed of light. So Newton, that hadn't even been considered, and Einstein was the very first person to, once we realized that the speed of light, or he and his colleagues did back at the turn of the early 1900s, that the speed of light was definitely a constant, and we were getting better and better at measuring exactly what that velocity might be. But when Einstein was first thinking about his passengers on the railway car and somebody watching the cars go by and flashes of lightning and all that, he didn't consider Doppler effect at that time. So that the point I'm trying to make is that relativity isn't ever going to work quite properly because it was never incorporated waves properly to begin with, or that's my opinion anyway. And it certainly has huge issues with quantum physics. And so let's talk a bit about quantum physics. Edwin Schrödinger, the physicist primarily associated, I think, in many people's minds with quantum physics, did point out a problem, and most people will, the problem with quantum physics, as it were, and most people will recognize it as the Schrödinger's cat issue, and that involved a mind problem where a cat is inside a box. You can't see what's inside the box, and you would have a certain amount of radioactive tainted food in there, and you wouldn't really know if the cat was dead or alive at any given time. And that's because when they were dealing with the electron, which is one of my buddies in the universe, one of the most fundamental particles in the universe is the electron. It's the smallest and most abundant, this is my electron, solid thing we know of, and if it can be broken apart, there's no certainty that it can be, but if an electron can be broken apart, it'll probably turn into smaller particles which we would recognize as gamma rays. The parts would be the gamma rays. And in my worldview, there are 20 of them, and there are 20 gamma particles in every electron. That's just my opinion. What do I know? I think I know a lot, but that's my opinion. I think a lot about myself, and I don't give a crap what you think. If you're here, I'm trying to put an idea into your head about absolute time. So I'm up to nearly 10 minutes already. I yak out and on, so let's cut to the chase here. And because in quantum physics they deal with basically the theoretical center of the electron, quantum physics does not deal with the here-ness and there-ness at the exact same time. They deal with the motion of the electron, its spin, or its any kind of motion. So an electron at rest is not, if it was at absolute rest with no motion, it would be really problematical for quantum physics because all its values are good as zero. That can't be right. It's still there. So generally speaking, that in the mathematical issue is fixed by a little handy number called Plancks Constant. It'll help overcome a lot of those issues of there not being any here-ness or there-ness in the world of quantum physics for the actual physical particle of the electron. But the electron is, even the very largest quark, barely is around the same mass as an electron. Think of this, every proton and every neutron has at least 3 quarks each. And there's not just 3 different types of quarks. There appear to be other kinds of quarks, but in terms of their characteristics and their masses, quarks are way bigger than electrons. I don't know if I'm a bit dyslexic. I hope I didn't screw up back there, but in a proton there's 3 quarks, so the mass of the proton is 1,836 times that of the electron, nearly 2,000 times. So if you divide 1,800 by 3, you get 600. So every quark has, in theory, 600 times the mass of an electron. And when you bash protons into each other, along with the quarks flying off, there's a lot of radiation, and that radiation is electrons. Protons and neutrons, certainly neutrons, contain an electron. That's the big difference, really, it would appear, between a proton and a neutron, is that a neutron has an extra electron over a proton, and the proton will be happy if an electron will get cozy with it, but not too cozy. It can't join, but it can be there. And in my view, a proton is a lot like a donut shape, and the hole is just too small for the electron to go through. So the electron, just depending on what kind of spin it has, would like to be in one of the, there'll be an indentation, and this is my view, that the electron will settle in there, because all things, in my view, follow the laws of flotation. I think of the universe as being continuous. There is no space. There's no empty space anywhere. All there is smaller and smaller and smaller and smaller particles. And the reason we don't recognize them is we are entirely dependent upon electrons. We can't view anything unless an electron passes the information to our brains. And the speed of light is approximately 1 foot per billionth of a second. So it takes approximately 1, 2, 3 nanoseconds for my finger to transmit electronic information to my brain, and another 3 nanoseconds to pass it back. And it does it all by way of the electron that has that messy little Planck's constant in the way. So how can we tell the size of an electron? By definition, we have a coulomb, which is a given number of electrons passing a point in 1 second. So we know what that number of electrons is, so all we have to do really is take the measurement for the speed of light, just a bit less than, 297, geez, I'm forgetting it today, just less than 300,000 kilometers, not meters, 300,000 kilometers per second. So how many electrons would that be in 300,000 kilometers? We can actually figure out what the distance from here to there is just by definition, if no other way. And knowing that, we can start thinking about the speed of light, because nothing can get from here to there in our reality except by way of an electron. So the electron, the physical distance of the electron, controls the speed of light. So in the whole gist of this, I'm up to 15 minutes. I hope you followed me, and I can be a little, I don't mean to say the opposite of what I mean to say. I hope I haven't done that anywhere. So the speed of light, to me, in my reality, is set by the physical size of an electron. You need to know that. That's not common theory. That's my theory. And once you start getting that concept, which is extraordinarily simple once you start to think about it, and you think of the universe as being continuous matter, that there is no empty space, just different sizes of things, and that the only thing that can get to us is enough energy that can move an electron its own diameter, which we would call one quantum. We would call that a quantum leap. It's one quantum of energy, or one photon, if you want to package the energy. So the energy is one photon. A photon is not light. It takes a whole lot of photons before you perceive light. Just because this thing moved once, that ain't light. It's got to move a whole bunch of times, a certain distance for your brain to register it as light. Where were I? So once you start recognizing the idea that the electron controls your reality, and that we live in an electronic universe, then it crosses your mind that we already are living at light speed. No information can reach your brain except at light speed. So it's not out of the rounds of probability and not too wacko to think the universe is already moving at light speed. We're just dragging behind as standing waves within a universe that is, light speed is just its normal speed, because it's the speed at which the tiny solid things recognize flotation. Things, if there's less pressure this way to the electron is really a monopole. It can have spin, which will give it magnetic kind of poles, but it's trying to find rest, and if more pressure is coming from any direction, it'll move away from that pressure, which is more electrons. So if there's less electrons that way, the electron here will go where there's fewer of them, and we know that for sure because that's the way a cathode ray tube works. You just strip that front screen of its electrons by sucking them out with many thousands of volts, and they're just a shortage of electrons. So the way a cathode ray tube works is you put all of this mess inside a really big tube, a vacuum tube, and at one end you put a heater with a little bit of metal that's conditioned to easily give off electrons and not melt on you, similar to the idea of a light bulb. And when electrons get heated up, they start jumping out of their orbits into what you think is free space, but it's just dark matter, dark energy. There is no such thing as empty space in my reality. It's just smaller stuff that electrons are the bullies, and they just push. It's nothing to them, and unless it's all lined up the same way, and then it's magnetism. Magnetism is, to me, just organized dark energy. We already use gravity all the time. It's called electricity. To me, in my reality, gravity, we're creating electricity is gravity, and we control it through wires, but that's another story. So the whole point of this was that Isaac Newton didn't know about electrons, and Isaac Newton didn't know about the speed of light, and Isaac Newton didn't know about Planck's constant being this necessary little nasty number where nothing will work unless you just throw this number in. And Einstein, when he was trying to work it all up, came up with this gravitational constant, which he didn't really like. And even Einstein recognized there's this nasty little number that if you just don't fit it in, nothing's going to work. And for some reason, it's always that number, so use it. So I suggest that Planck's constant is nothing more than a number directly related to the mass of the electron and nothing more. It's sort of like the absolute at-rest mass of the electron, and the entire universe is operating at light speed. It's only we humans, we sluggish humans, that are walking around with standing waves of light, basically. This isn't light, but light is just of the types of energy, light is just a very little piece of it. Light is like a grain of sand on the beaches of the world in terms of the range of energy that is possible. And we are just the right size and in the right place, that electrons are our very convenient measure of everything. We are light speed beings. We all are already happening at the speed of light. It's only our bodies that are, they're traveling at the speed of light too, but they are what, if you're a physicist, it's still a mouthful. If you're into physics, you'll know what a standing wave is. So we are just standing waves of energy, highly organized energy, which wants to be at rest. Everything wants to be at rest. I don't believe in gravity. To me, gravity is push, not pull. The reason things are going towards Earth is spinning, and in terms of motion, spin slows space down. It's a place of rest. And it may seem counterintuitive, but spin is a place of rest. If you go to the poles of Earth, the North Pole and the South Pole, they have the least rotational spin. So time, in theory, is happening faster there. And at the equator, where there is the most rapid rotation, time, in theory, believe it or not, it might only be so slow you won't notice it, you blinked, you missed it. Time is actually happening more slowly at the equator. I know it sounds wacko, but that's the way things are. So I didn't want to make this long. What I wanted to suggest to you, because I've learned in my old age that if I don't write something down, I'll just forget it. I'll forget it 10 minutes later. I'll forget that I even thought about it. And so I'm trying to be more useful, and instead of just staggering around all day, wondering what to do because my arthritis is bothering me. It's not bad now. It was pretty bad this morning. So I had all morning trying to deal with my arthritis not going away, and now I'm feeling better, and maybe it was the extra T3 that helped, and several pipefuls of pot. Pot is legal as of now in Canada. I can legally smoke dope. Hooray! So Butchie Poo is coming up almost to 25 minutes. If you're here, you're probably into physics, and I want you to, there's several things I suckered you into coming here. So I pulled what do they call it? No, I can't think of it. I Rick rolled you. Anyhow, because I want to keep stressing the idea that I believe the speed of light is simply a repercussion of the physical here-ness and there-ness at the exact same time as the electron. The electron sets time, and it can either rotate or it can move. And the amount of energy to do either is going to be, it would appear, one quantum of energy. So to get this thing to move one diameter, you're going to have to push in excess of one quantum of energy from this side to what there is there. And so if an atom absorbs energy, it can push itself further out into space. Remember, to me, David Silvercloud, gravity is push, not pull. And if you get imaginative and you just think, well, that doesn't really defy any rules of anything, and it really helps to explain why an elephant and a mouse fall at the same time in spite of the differences of their masses, right? You know, you can drop the Titanic and an elephant from the same altitude and they'll both go splat on the ground. If you ignore air resistance and wind currents and any of that kind of crap, they'll both go splat at exactly the same time, which gravity has real problems with explaining. But if you think of them both being pushed, they both had the same force on their backside, not on their front side. Not it's blow, not suck. That's a Bart Simpson line, isn't it? Or is it, I don't know, is it suck or blow? Anyhow, let's not go that way. So Butchie Poo is going to sign out on you here. You can check me out. I'm an artist and visual artist into theoretical physics with all my own ideas about everything. And you don't have to believe any of them. I'm trying to get you to think. Use your noggin. Just because somebody told you something in school doesn't mean it was true. They were just preaching whatever they were told to preach. You should be asking questions all the time about everything. That's supposed to be what science is all about. Never stop asking questions. So Butchie Poo has his arrow down on the red thing there. I can see it. And I'm sure I've rambled on more than enough. So I'm going to go like 5, 4, 3 and all that. And I'm going to hit the button. So 5, 4, 3, 2, 1, bye.